Hi, my name is Grant Dower, and this is my Physics 2212 Lab 1 charged tapes. For an introduction, the purpose of this lab was to observe and record the transfer of electrons between pieces of tape and the interactions between these charged tapes. Some principles that we use in this lab are Newton's first law, which we will use to record the gravitational force exerted on the tape, and Coulomb's law, which I use to observe and measure the electric force that each tape exerts on the other. Some assumptions are that each piece of tape will be modeled as a point charge when using Coulomb's law, air resistance is negligible, and both tapes will have the same charge. For experiment details, first I will get two neutral pieces of tape, also called U-tapes, and rip them off of a base tape that is stuck down onto a table, and this will charge the tapes, and then I will observe interactions between the U-tapes and other objects to determine the sign of the U-tape charge, and then tape one U-tape across the gap to create a bridge, as shown in the diagram right here. Bring the second U-tape close until the bridge tape starts floating from being repelled by the other U-tape, as shown here, and measure the separation distance between the tapes when the bridge is floating. The system of the experiment is the bridge tape, tape B in the diagram. The surroundings is the tape being held below the bridge tape, tape A. The initial conditions is the only force initially acting on tape B is the force of gravity. Results of the experiment were that the charged tapes repelled each other. The tapes both had a positive charge because they were attracted to a negatively charged pen. This pen was charged through rubbing it through my hair, giving it a negative charge through an excess of electrons. The bridge tape started floating when it was separated from the other tape by a distance of 0.287 meters. The charge on both pieces of tape is 1.37637 times 10 to the negative 8th coulombs. For this experiment, we are assuming both tapes have the same charge because they are charged through the same process. The efficiency of electrons on one piece of tape is 8.6 times 10 to the times 10 to the 10th electrons. There are 4.9 times 10 to the 6 atoms for each electron on one piece of tape, and tape mass is 0.000211 meters, tape length was 0.201 meters, and tape width was 0.020 meters. Code for my experiment, it takes in values that I recorded, such as the tape's mass, length, width, and the distance between the tape when it started floating. It outputs the values of the charge on both pieces of tape, the deficiency of electrons on both pieces of tape, and the ratio between the atoms to the electrons on each piece of tape. And it does this by calculating the electric force on each tape needed to cancel out the gravitational force on each piece of tape, shown here. Some possible sources of error in my experiment could be my hands or other objects touching the tape, which allows the tape to lose its charge or gain electrons over time through this contact. The measured weight of the tape is an estimate using a rough grams per meter conversion that was given for the experiment, and any additional unaccounted for forces from other surroundings on the tapes. For conclusion questions, what if the sign of protons and electrons were switched? This wouldn't matter for the experiment. The results would remain the same because like charges would still repel and opposite charges would still attract. And in this case, the electrons being removed would create a negative overall charge on the tapes, but they would still end up repelling each other, causing the tape to float, opposing the force of gravity. And why is it important to handle the charges as little as possible? What happens when the charged tapes come into contact with your hands or other objects? This is important because charged tapes will lose their charge over time when coming into contact with our hands and other objects, as I stated earlier. This is crucial for the experiment because we need to conserve as much charge as possible on our tapes. Thank you for watching.